All right, people, in this video we're going to be talking about solving systems using substitution. Now, one key thing that I want everybody to understand is that we could graph these equations and find them on the coordinate plane, which is why our solutions are going to end up as ordered pairs. And so understand that we just have two linear equations, but instead of graphing them, we are now just going to solve them algebraically. And our first step to learning how to solve these things is something called substitution. Now, the best way to identify that the use of substitution would be the best route in solving them is to see a y equals or possibly x equals. All of your practice problems here, 1 through 4, all have y equals, but you could certainly have x equals if that were the case. And so a very distinguishing mark that you are going to use substitution as the method of solving the equation or solving the system is that it has a y equals or x equals. Now, what you understand is when we get into the elimination section, which is our next part, that you can manipulate these equations any way you want algebraically. If substitution is your favorite thing, then you could definitely switch things around so that a substitution is the way. But we'll kind of see as our process goes on in class. And so our first thing I need to do is I do identify, let's see number 1 here, is that I do identify that it is a substitution problem because the fact it has y equals. So the key thing to understand about substitution is that y equals this expression, 7x plus 10. So these are interchangeable, okay? 7x plus 10 equals y, and y equals 7x plus 10. Meaning that my hope by subbing it in, or the truth is that if I sub this in for y, this expression right here, in for y, that is the same as having y itself, okay? Because they are one and the same. Similar to like a basketball situation we talked about in class, which is if I substitute a player off the bench, I hope, and as a coach, is that player's ability is the exact same as the player that he's subbing in for. And so that's very important to remember, is that substitution, kind of associated in real life, is that I'm going to plug in 7x plus 10 for y, because they are equal. They're the same things. All right, so let me give a clear example of that. Equal sign's a little bit nuts there. Y equals 7x plus 10. And then this is negative x minus 3y equals 14. Okay? So what we're going to do here is we are going to take 7x plus 10 and we are going to put that in for y in the other equation. So my new equation is negative x minus 3, and whenever I plug an expression in, a number in, anything, I'm always going to put parentheses around it. A, because it makes sure I don't forget about any negative sides, and B, it establishes that I do need to distribute out whatever's in front of it. Okay, so I have 7x plus 10 and then equals 14. Okay, understand what I just did was, and let me show this with colors. Maybe that'll help out just a little bit. Let's see here. So let's say my blue is 7x plus 10. And let's put in green is my y. Okay? And so what I just did was I plugged in 7x plus 10 in for my y. So I replaced it with this expression. Okay? And so it's very important to understand what is going on here. And like I said, this is a light bulb concept, meaning that once you see it, it's like, oh, I understand. We're plugging in 7x plus 10 in for y because y equals this expression. So now I'm in a good place because now I can solve an equation because I have only one variable involved. So I have negative x, I'm still in blue, even though blue does look nice, negative x, and what I have to do is I have to distribute this negative 3 to every term inside the parentheses, okay, distribution property. So we have negative 21x, so negative 3 times 7, negative 21x. Negative 3 times 10 is negative 30, and we get 14. Okay? The most common mistake I see people make is they do get the first term multiplied, but they forget to distribute to the second term. All right, so make sure you do that. We're going to combine like terms. So we have negative x and negative 21x, so that makes negative 22x minus 30 equals 14. All right, and our next step is make sure I get this all correct. I don't know if okay, I got this all good. And then my next thing is I'm going to add 30, so negative 22x equals 44. And then we divide by negative 22, and x equals negative 2. All right, so up to this point, the idea of solving these equations, we've studied this before in previous units, of just solving an equation, combining like terms, solving for those, and then we get an answer of -2. Now we're not quite done yet because we have one of the points, we have the x variable, but we do not have the y variable. So what we need to do is pick out one of these equations, either the first one or the second one, and plug x into it and solve for y. My recommendation is the first one, just because it already has y equals 7 times -2 plus 10, which will result in y equals -14 plus 10, or y equals -4. Alright? So, with that said, we are now going to finish up by writing these as as an ordered pair, because, again, emphasize what I talked about at the beginning, which was that if we were to graph these points, or graph these lines, that it would result in one solution, or they would cross each other once, and therefore would be a point. So we're going to write this as a point, a ordered pair of -2, -4. Again, this stands for the x, this stands for the y, and so that is the point of intersection. Alright, so that's one down. I don't think I'm gonna get to 3 and 4, but I'll at least get them started for you so you have an idea. So what I'd like you to do now is take a moment and see if you can solve number 2. Okay? So pause the video and see if you can go through the process of solving number 2. Alright, welcome back, and here we go. This is number 2. Okay, so -x minus y equals -6, and y equals 5x minus 12. Again, we have a substitution problem on our hands because we do have one of our variables solved for. So what we're going to do is we're going to plug this in. I'll kind of do the same color coordination as I did the last one. 5x minus 12. And I'm going to plug that in for y. So it's going to take the place of y. Now this is where the parentheses become very important, because you'll notice that I have to account for the negative sign out in front. If we don't do that, that's probably where, if you made a mistake or didn't get a nice answer, that's where your first problem is. We put this in parentheses because it does make sure that we do distribute the negative. It's actually a -1 in front, but we do need to distribute the negative sign. So we have -x minus 5x plus 12 equals -6. And so our next thing we need to do, again, we go through the process of solving an equation. -6x plus 12 equals -6, minus 12, minus 12, -6x equals -18, and so x equals 3. So you should have got an answer of x equals 3. And now, again, we're not done yet. We still have to solve for the y now. And I'm going to choose that second one again. But understand, if you chose the first one, you do get the same answer. So we have y equals 5 times 3 minus 12. So we get y equals 15 minus 12, and so y equals 3. So my point of intersection, or my solution to this problem, is 3, 3. All right. So hopefully this video helped you out a little bit. I didn't quite get to 3 and 4, but these do come from your practice problems that we handed out in class. And so hopefully you're able to work on these. I will set up the first one for you. So if you're working on number 3, it first starts out as, if we do plug that in, all right. So hopefully that's a good start. These numbers get a little bit bigger than our traditional other ones, these first two that I worked, but you should be fine. And again, practice, practice, practice. The best way to learn this substitution process is through doing multiple problems, and hopefully you don't make mistakes. The common mistake, again, like I see, is that people forget to distribute that the coefficient in front, or they forget to distribute to the last term or the other terms in the expression. So make sure you account for that. Thank you very much, and please come with your questions. Bye-bye.